In this video we'll look at how we calculate equilibrium concentrations for reaction where we have the equilibrium constant given, and you can see the actual problem here. In this video we'll look at how we can calculate equilibrium concentration for a certain reaction if the equilibrium constant is given. You see the problem that we're going to work with up here, and the reaction that we'll work with is given, is this one, and the equilibrium constant is this one, it's 0.771. The equilibrium constant, as always, is given for a certain temperature. And the problem itself is formulated like if we have 0.01 mole of hydrogen gas and 0.01 mole of carbon dioxide, if they are mixed in a 1 liter container at 750 degrees Celsius, what are the concentrations of all substances present at equilibrium? So we understand that hydrogen will react with carbon dioxide to form water and carbon monoxide. That's a given. But how do we go about solving this task or this problem? Well, first we have to realize that the molar the concentrations will be. First, we have to realize that since we have 1 liter container, the concentrations will be equal to the mole of each substance, which simplifies a little bit for us. We also see the relation between the different components in the reaction is 1 to 1 in all cases. So 1 mole of hydrogen gas reacts with 1 mole of carbon dioxide to form 1 mole of water and 1 mole of carbon monoxide. And that's quite convenient. The way to go about such a problem is to set up something called ice table. And we write it like this. And in the ice table, the I stands for initial, C stands for change, and E stands for equilibrium. So what we'll do in this table, we'll write down what we have initially, we'll define the change in the system as the components react, and we'll write an expression for the equilibrium concentrations as well. So, and we'll do this for each component in the system. So we have hydrogen gas, we have carbon dioxide, and we have water, and we have carbon monoxide. And initially, as it was given in the problem, we have 0.01 molar, mole per liter really, of hydrogen. We have 0.01 mole of carbon dioxide. That's what we put in this 1 liter container. And at the very beginning, very start of this reaction, we have 0 water and we have 0 molar carbon monoxide. And as I mentioned, when these components react, when the reactants react, we can set this amount, the change here, we set it to minus x. And same thing here, because x mole of hydrogen will react with x mole of carbon dioxide and will actually form 1 mole of x mole of water and X mole of carbon monoxide, like I said before, since the molar ratio between the components are 1 to 1 to 1 to 1. This becomes quite simple. And then it become rather easy to define the equilibrium concentrations, because we start with 0.01, remove X mole of hydrogen. Same thing for carbon dioxide. And here we'll have actually X, since 0 plus X is X, right? Okay, so far so good. So let's look at the expression for the equilibrium constant, Kc. As you probably know, this is defined as the concentration of the products, and the products are water, carbon monoxide, the product of these two over the product of reactants, which are hydrogen gas plus carbon dioxide, like this. And this was given in the problem. You know that this is 0.771. And then it becomes a matter of, at equilibrium, putting in the expression that we derived in the ice table. So that means that if we substitute in this expression, we will have actually X multiplied by X. This is water and carbon monoxide. And here we'll have 0.01 minus X multiplied by 0.01 minus X, like this. And we simplify this a little bit. This is X squared. And 0.01 minus X squared as well. And to solve this, this is basic algebra, which I'm sure you know. But by taking the square root on both sides, this is 0.771. So if we take square root of each side here, we'll get an expression looking like this. And that means that X will be and if we move ahead to solve this, X will be 0.00468 mole per liter. And with this we can actually write the answer to this problem, which is that the product, the concentration of the product at equilibrium will be, well, hydrogen gas will be the same as carbon dioxide for the reasons we mentioned before. It will be 0.01 minus x, right? And x we calculated to 0.08, which will be 0.0053 mole per liter. And for the products, water, have the same concentration as carbon monoxide, and that will simply be equal to x. Okay, so then we have arrived at the answer to the problem, and the concentration of hydrogen and carbon dioxide will be 0.0053 mole per liter, while the concentration of the products, water and carbon monoxide, will be 0.0468. I hope this showed you how to solve this type of problem, and I hope to see you again next video. Thank you.